Hi, everybody. So in this video, we're actually going to tackle two different pages in the problem set. One is a demonstration that I always like to do with students, and unfortunately, I'm not able to demonstrate it with you because we're not together, but I do have a YouTube video that I'm going to link and show you what to check out. And then the second part is related to this concept after you've learned what utility is. So let's get started. So utility is just the idea of your personal satisfaction that you would get from consuming something. So we have a hard time kind of explaining it in concrete terms because it's not a real phenomena. But if we just kind of said, how much did you enjoy that on a scale of 1 to 10? And so we sometimes we can quantify it and say, well, we have a util is actually the unit. And we'd say, well, I got 12 utils, which is like basically saying I got a lot of enjoyment. There isn't like a conversion ratio of utils to actually anything in reality. It's just a philosophical abstraction that allows us to think about consumption in a useful way. And so what we observe is that as you consume more of a good, right, generally every time you consume, like let's say you have donuts in front of you, right? You have a donut, you eat the first one, you'll get a substantial amount, assuming you like donuts, you'll get a substantial amount of utils. And then you consume the next one, and you might get a little bit less utils out of that next one because you've had the first one already, and they're all the same, right? You're gonna have the same donuts here. And so we'll kind of do a quick little quantity of donuts, and then we'll say utils, and we'll say like total utils, and then we'll say marginal utils. And so marginal is a word we haven't really used very much in this class, but it just means additional. And so the additional utils from each unit. Now, if you have 0 donuts, right, then you have 0 utils, and there isn't really a marginal because there isn't an additional one. But the first donut, let's say, we'll just use this table here. Let's say it gives you 15 utils. And so the total amount of utils is equal to the marginal because you've only had one. But the second one that you eat, and we'll again keep using the table, gives you 13 utils of benefit. And so we add that to the ones you already had. So now you have 28 utils, right? And now let's stuff your face even more with a third donut, and that one gives you 11 utils. And so you have a total of 39. And 4 and 9, and that's 48. Hopefully I can do math. 5, 55 is the next one. So it gives you 7 and so forth, right? You can kind of see that here. And we can actually say, pretty clearly that what starts to happen is that they usually takes off and then it starts to flatten out. And it flattens out, and then at a certain point you're like, whoa, too many donuts. Blah. And actually your total utility, right? If we have TU there for total utility, will start to fall. And you can see that in that example down below, the 9th clam, whoever this person is, they had negative utils, or they negative marginal util anyways, because it made them feel less satisfied than before. And we can graph a marginal utils, right? And what we find, so I'm just going to cross that out because it's not useful for us. But what we find for marginal utils is that typically, with that very first, the 0th quantity, and then the in-between ones, these aren't really these, it's more like utils. I'm such in the habit of writing P's and Q's, but it's utils. It's up here, it's between the 0th and the first one. We know that it gave us 15, so that would be like 15 utils. And then between the first and the second one gave us 13 utils, and we'll kind of usually find that they do one of these. So a marginal utility curve is usually just a nice straight line. Now, one thing to observe if you're a more math-oriented folk is that actually this marginal curve is the derivative of the total. So if you know calculus at least a little bit, it's basically the slope of this line at any given point, and we can regraph it down here. So anytime you see like a total something in this class and then there's a marginal something, the marginal function is just the derivative of the other one. Now, we're going to use what we learned about utils here, which is pretty basic stuff, to go into the next topic and explain why it matters, right? And so it's answering 3 questions for us. How much of one product to consume, which of 2 products to consume, and then how much of 2 products to consume. So 3 different questions, all we can answer with utility. Now, the very first one says consume until, so if we're deciding like we have one product and how much we want to consume, you consume until the marginal benefit equals the marginal cost. Now remember, marginal just means additional, right? It means additional. So the additional benefit of each unit has to equal the additional cost. And once we're there, we stop consuming, because probably the next one that we consume, we're not going to get as much benefit from. Remember, we have this idea that you don't enjoy it as much as the next one. And in fact, this marginal utility is another way of saying marginal benefit. So we'd say that additional satisfaction is diminishing throughout the entire range. And this is actually so important, it's a law in economics, that at some point in quantity, and we're going to write this down, it's actually kind of written here, each successive unit, but I'm going to state it to you verbally. At some point in quantity, successive units of a good or a service provide less utils than previous. It's true for every single good in existence, every single one, no matter what. Don't you can come at me, bruh, but I'm telling you, it's true for every single good and service. If you had like one sitting and you were like, okay, here's one, here you go. Now here's another one, here you go. Every good or service, right? That's really important there. And it's, we don't usually call it the law of diminishing additional satisfaction. That's a, a translated version. We call it the law of diminishing, because it is diminishing. They are slowly decreasing. Diminishing marginal utility. And that's all it is, the law of diminishing marginal utility. So let's go ahead and see this in action here with slices of pizza. The very first slice of pizza gives you go from 0 to 8, and so there isn't for the 0th, but there is 8 here. And then this one gives you 5, and 2, and 1. So we can see that there is diminishing marginal utility here. Now the marginal cost of the pizza is the additional cost that it cost you to buy a slice. So assuming that for this purposes that a util is worth like $1 in your head, that will kind of allow us to do this. The $2 per slice tells us each one's cost. Now, there isn't an additional cost for the 0th unit, but for the first one there is 2. And what about for the second unit? Now remember, this isn't the total that you spent on pizza, it's just how much did the second slice of pizza cost? $2. How much did the third cost? $2. How much did the fourth cost? $2. So for these, right, we're going to consume up until the marginal utility equals the marginal cost. And so we would say you should consume the third slice, but not the fourth, because the fourth one doesn't give you as much bang for your buck, is the kind of phrase that we use. Now decide how or which of 2 products to consume. So that's our second question that we can answer. And I'm going to skip through this because we already did this part already. And in fact, this one's not 1, it's -1. I just noticed that. So this is a negative utility. So you would never consume that even if the pizza was free. And we already talked about marginal utility. So how to decide which of 2 products to consume? This is pretty straightforward. Basically, you determine their marginal utility per dollar that you spent, right? And choose the bigger one. So what I said, the bang for your buck, right? It's literally the marginal utility, the bang for your buck, divided by the price. And so in this case, right, we'll assume you want to attend either Washington University in St. Louis or Stanford. And for Washington University, you have to live close to home, and maybe you're like, I want to get away, but it's cheap because maybe your parents work there or something. I don't know. So we would say 2,000 over 10,000, that's 0.2. You're getting marginal utils per dollar that you spent. And for Stanford, you get 4,000 because you're living really far away in California and it's cool. And divided by 40,000, you got to pay full freight. So this one is 0.1. So which one should you do? Well, you get more bang for your buck by going to Washington University, because 0.2 is bigger than 0.1. So that's what we choose. Now, the third question, we'll skip through those, is how much of 2 products to consume. So in this one, you're going to have a couple of moving parts. Usually you're going to be given the question and it'll say you have this much money to spend and you can spend it on 2 things. One, how much of this and how much of this. And you're going to give limited resources, right, budgets. And then the next step is you determine the marginal utility per dollar or per price for both goods at every single level. And then you find where those 2 are equal and you check that you've used your entire budget. So again, I'm just rereading this text to you to explain it, but I think it helps to work through a practice problem. So let's do this. Assume you earn $11 per week and you consume either bagels or pizza slices. And so I've already done some of these for you, right? So if you kind of want to think about it, I've actually done the pizza side for you, where you can see the first slice of pizza, you get 8 total utility, 8 marginal utility. And so the pizza is $2, so 8 marginal utility divided by 2 is 4. If we look here, the next marginal utility is 7 divided by 2 is 3.5. Now, students sometimes will somehow do something different when they're dividing. In these, you're just dividing by the additional cost of that unit. So that would be $2, right? So each time it's just 6 divided by 2, 5 divided by 2, 4 divided by 2, 3 divided by 2. Now what we're going to do is we're going to compare this column, the marginal utility per dollar of pizza, to this column, the marginal utility per dollar of bagels. And we're going to see where they're equal and where we use all of our budget, and that'll tell us how much we're supposed to consume. Now, let's go ahead and do this one. Each bagel is $1, so this is actually going to make the math pretty easy. It's 10, the MU, divided by $1. So that's 10. 8 over $1 is 8. 6 over 1 is 6. 4 over 1 is 4. 3 and 2. So the math's not too bad on those. And now what we're going to do is we're going to look to see in these two columns, and I would really strongly encourage you to take your 2 fingers, right, and put them on those 2 columns and just kind of move your fingers down and see, do we find any equal? And we do, right? We see here's a 4 and here's a 4. Now we're going to test this one. So I'm going to put a little dot here and a little dot here. Now let's test that. How much do 4 bagels cost? Well, this one would be $4 because they're $1 a piece. How much is 1 pizza? Well, it's $2. And I'm just writing how much like the total you spent would be. And if you spent 2 and 4, you add those together, that's 6. So you would spend $6 to buy 4 bagels and 1 pizza. But you earn $11 a week. So you could buy more of both and be better off. So that's not the correct combination, right? Let's take a look again. Let's take our pointing fingers, right, and move to the next one, 3.5. We don't see that. 3. Now we do see a 3 here, so let's test this one, where it's 3 and you have 3 and 3, right? Those are the numbers that we're matching. Remember, we're matching MU over P, and so 5 bagels costs us $5, and then this one goes with 3 pizzas, and so that would be $6. $6 plus $5 is 11. So that is the correct answer for how many pizzas and bagels we should consume. 3 pizzas and how many bagels? 5. Now, if you want to test it, let's go ahead and test it and see what's the total utility from these. 10, and then plus 8 is 18, plus 6 is 24, plus 4 is 28, 31, and 33. Now you can run through any other combination that uses all $11 and doesn't go over, and you will not get any greater utility than 21 plus 31, which would be 52. And you can test it out, right? You can play around with different combinations all you want. You will not end up with something greater than that because the utility maximizing rule is in play here. Okay. Now, why would you not consume, before we go too far in this, 1 pizza and 4 bagels? Well, thinking about that, we already established you wouldn't buy 1 pizza and 4 bagels because you're not using your whole budget. Why not 5 pizzas, right? 5 pizzas and 6 bagels, which would give you 63 total utility. Well, you can't afford that, so that's not okay either. So this is our utility maximizing rule, and in fact, it's just restating what I just told you. You should consume, if you have 2 goods, X and Y. Consume X and Y until the MU of X of the last unit that you consumed over the price of that unit is equal to the marginal utility of the last unit of Y divided by the price of Y. And I put a little addendum here. If the MU over P is not equal, it's a fairly straightforward process. Consume more of the good with the higher MU over P and less of the other good, right? Because you have a budget, you're using the whole thing. So thinking about like if you had the wrong combination and you had to reallocate, if you had, for example, if the MU over P and the MU over P were, we'll say 5 and 3, right? So here's the trick, right? If instead we said 5 and 3, well, those are they're not equal. This one's bigger than this one. So which one should you consume more of? Well, you should consume. We're going to draw a little Pac-Man with teeth, right? And we'll kind of make it like a dragon. you should consume more of that thing because the mouth wants to eat it. So consume more of this one and less of that one when you have the numbers that aren't equal. All right, hopefully this helped you. I'm going to put a quick link up here in the top to a good Jacob Clifford video that also illustrates this. Bye.